Let's take a look at three basic laws of force and motion. Going over them can help you see how force and motion are related. The first law states that when an object is not moving, it won't start moving unless a force is applied to it to overcome its inertia. Inertia is a property of matter that resists changes in motion. An object that's not moving remains at rest because of its inertia. And when an object is moving, its inertia causes it to continue moving in a straight line unless a force is applied to it. Inertia relates directly to the mass of an object. So the greater the mass of an object, the greater the inertia. And the greater the inertia, the greater the force required to start an object moving, stop a moving object, or change a moving object's direction. Now, the second law deals with the applied force. Simply stated, the second law says that force, F, equals mass, m, times acceleration, a. Acceleration can be defined as the rate of change in velocity over a given unit of time. A change in velocity may cause an object to either speed up or slow down. So basically, acceleration is a measure of how fast an object changes speed. That is, either speeding up or slowing down. For example, as a result of an applied force, this ball accelerates from zero velocity to its peak velocity. To understand this better, let's look at the action again, but this time we'll use a scale to show distance and a clock to show time. If the ball moves 2 feet in the first second, 4 feet in the second, and 6 feet in the third, it travels an additional 2 feet for every second that passes. In other words, it accelerates at a rate of 2 feet per second per second. Feet per second, or simply feet per second squared, is a common unit of acceleration. Just about anywhere there's motion, the relationship of force, mass, and acceleration is applied. In the flow of fluid, in the movement of solids, or in a moving vehicle. A good example of the first two laws at work in the plant can be seen in a pump startup. Here's a cutaway illustration of a centrifugal pump. We'll slow down the action so that we can explain what's happening. Before the pump is started, the fluid in the system is at rest, and its inertia tends to keep it there. The fluid has a velocity of 0. When force is applied by the pump, the fluid starts moving. The applied force causes the fluid to accelerate from 0 velocity to its final velocity. Once the fluid reaches its final velocity, the applied force and the fluid's inertia will keep it moving at a relatively constant speed. In this case, although the fluid starts at rest with 0 velocity, applying a greater force causes its acceleration to be greater and its final velocity to be greater. The third law of force and motion we'll look at states that for every action, there is an equal and opposite reaction. In other words, if a force is applied to an object, the object applies a force that's equal, but exactly opposite in direction. This law is usually referred to as the action-reaction law. The force that lifts and moves a rocket into space is the reaction force that results from rapidly moving gases that are created by the combustion of fuel. In the plant, an example of the third law can be seen in this demonstration using a compressed air hose. The movement of the hose is caused by a reaction force that's produced when air flows rapidly out of the hose. Another example is the pipe supports that keep pipes from moving when the fluid flowing through them makes a turn. As the fluid makes the turn, the pipe exerts a force on the fluid. And the fluid exerts a reaction force on the pipe, causing it to try to move in the opposite direction. So the three laws give us a means of analyzing forces and motions. In this topic, we looked at force and motion. We saw how force and motion are related, and we discussed three laws of force and motion. Nearly every aspect of plant operation is affected by force and motion, so It's important for you to have an understanding of the concepts that we covered. Now try some practice questions. Force, like the force that pushes this ball, can be defined as a push or pull on an object. Because of the applied force, the ball is in motion. Motion can be defined as a body changing position. Gravity is a force that acts on all objects on Earth. Gravity exerts a downward force or pull toward the center of the Earth. Now, the second law deals with the applied force. Simply stated, the second law says that force, F, equals mass, m, times acceleration, a. This ball is in motion because a force was applied to it. What would happen if a greater force were applied in the same way? What force causes these boxes to fall to the ground?